Hello there. Let's try tackle this question. So, a bit of an awkward one. You're first of all asked to shade in two regions that are empty, other than this one here. This one here is pretty straightforward in that G, you're told in the question that G is the set x plus yi, where both x and y are integers. So this area here, you know, is for reals that aren't rationals or integers, i.e. it's outside the set of rationals and outside the set of integers. So the area in here is only for real numbers that aren't rational, i.e. irrational numbers, root 2, pi, e, etc., etc. So any number in here could not be of the form x plus yi, where x and y are rational. These numbers in here, okay, the problem here is that if a number is in here, say for the example number 4, surely 4 can be written as 4 plus 0i, so therefore it should be in here. So any number, any integers you can think of can be written as the integer plus 0i, therefore it belongs in here, because this is the set of complex numbers where they're both integers, and 0 is an integer, so any number plus 0i is an integer, therefore all the ones that you'd imagine would go in there actually go in here, and there's no integers that aren't in this set. So that's the first part looked at. The second part then was we had to put in a heap of points into the various positions. I can't remember the order they're in, but let's just go through them anyway. It doesn't really matter the order. Root 2, well, root 2 is rational, or it's irrational, and it couldn't go in here because it's not rational. G, or it's not an integer. G is the set of complex numbers that are where x and y are both integers, remember. So root 2 must go here. Half plus 2i is a complex number, therefore it must be outside the reals, but it couldn't go in here. Whereas 4 plus 3i goes in here because it's complex, so it's outside the reals, but it's captured by this area here, which contains the integer x plus yi, where they're integers. Again, for the same reason as a half plus 2i, root 3 minus I. If root 3 was an integer, it would go in here. It's not, so it stays out there. A half itself is a rational number. It's, basically, it's not an integer, so it can't go in the circle, and it's not an integer, so it can't go in there either. So, grand. I think that's all covered there. I've 6 of them. I think that's it. And the last bit then is about the product AB, where A is, hold on, I can't even remember what this question is. Consider the product AB, where A is in G and B is in Q. Right, if A is in G and B is in Q, you're multiplying a rational number by some number like 4 plus 3i, so the result is going to be a rational number. I mean, the real and imaginary parts of the number, when you multiply them by a rational, have to be rational. They couldn't be irrational, which is this section out here. So that's why this is the only place where that cannot be. Okay, that's me done on this one. A few more to come.